Hello everyone. Now today we are going to start with the next chapter, which is chapter number 14, Symmetry. Symmetry, you have already done this in class 6th also. Now this time we are going to do three kinds of symmetry in this chapter. The first one is going to be the line symmetry. Second is going to be the point symmetry. And the third will be rotational symmetry. Now in 14.1 exercise, we will be doing these two firstly, and then in the next one, in 14.2, we will be doing rotational symmetry. And in 14.3, we will be doing the mixing of these three symmetries. Okay. Now in 14.1, we will be doing these two. Now let us see what are these two. Line symmetry you have already discussed or you have already studied in class 6th. Now for example, I am having this page. If I am having this page and I have folded it like this, okay, now if I have, just look, now it will be more visible to you. Now I have folded this page and you can clearly see that this page is overlapping the page which is on the other side. So you can see that you are not able to see the back side of this page. This means there is a symmetry. This means this page is in symmetry with this page, and if you will see, this is the line of symmetry. This crease which is making is called as the line of symmetry. This is the line of symmetry. Okay, on the basis of this, if I will see, the crease was formed, and if I'm going to close it, it is overlapping completely. Or you want to take the example of hands, you can see this is one hand and this is a second, and I can clearly put one hand on the other hand. You will not be able to see the previous side. Okay, so that means they both are in symmetry with each other. Similarly, if I'm going to fold this page like this, if I'm going to fold this page like this, again you will be able to see that this is the side which is overlapping the down one, right? So this means here one more symmetry is formed, and this I'm again going to mark it, and that is going to be your horizontal symmetry. Now if you will see this, okay, that is going to be your horizontal symmetry, horizontal line of symmetry. And if I was overlapping it like this, that was vertical line of symmetry. So these are called as the line of symmetries. Okay, now what if I am going to join the pages like this from the corners? If I'm going to join the page like from the corner, if you will see it like this. Now can you see, is it overlapping? Is it overlapping? No, it is not overlapping, because this much part is left. This part is left. That means I cannot say that this slanting is the line of symmetry. It is not the line of symmetry because it is not covering the other part of the page. Similarly, if I am going to take this corner and I am going to fold it like this, again if I am going to fold it, again you can see this much part is left which is not being overlapped or which is not being covered up. So that means this is also not a line of symmetry. And this page is in the form of rectangle. You can clearly see the form of rectangle. This means the rectangle is having two symmetries. One is vertical symmetry. The second is the horizontal symmetry. This was all about the line of symmetry. Okay. Similarly, if I take a square, this was the rectangle example. Now I'm going to take a square. Now if this is the page, I am going to overlap it like this. So yes, it is completely getting overlapped. So this means this is the line of symmetry. This is one line of symmetry. Okay. Now I can also do like this. I can overlap it like this also. So this means again one more line of symmetry is formed. Second line of symmetry. Okay. Now let us cover the corners. From there I have folded it like this. Now if you will see clearly, you can see, you cannot see the other side. Not even a single side you can see from the back. This means this is also a line of symmetry here. From the corner also we are getting the line of symmetry. So I am going to join it like this. From the center it is passing. Okay, this point is done. Now let us join this point. If I'm going to join this point, you can see again it is overlapping, and I can see that no other side it is visible from the back. So it is completely overlapping. This means this line is also a line of symmetry. Okay, so this is also a line of symmetry. Okay, fine. So these are now how many lines of symmetries? 1, 2, 3 and 4. So, and just tell me one thing, that in a square how many sides are there? In a square how many sides are there? If you will see, 4 sides are there, and in this square we just found that there are 4 lines of symmetry. So how many lines of symmetry a square is having? Line of symmetry, how many it is having? 4. Okay, now we are going to conclude on a result on the basis of this, but before that result you need to understand what is a regular polygon. A regular polygon means, firstly, polygon means a closed figure. Polygon means a closed figure, and regular means a closed figure whose all sides are equal. For example, this square. This is a square, it is closed, and all the sides of this square are equal. So from this I can say a regular polygon is having as many number of sides, it is going to have that many lines of symmetry. This is the result which we were discussing. Let me take out that page. This is the second point. Firstly, line of symmetry I have explained you, right? Next, a regular polygon of n sides has n number of lines of symmetry. For example, if I am going to make a pentagon, that also regular pentagon, that means all the sides are equal. This means if I am going to make a line of symmetry from here, it is going to overlap. From this side I am going to make a line of symmetry, it is going to overlap. From all the vertices, if I am going to make line of symmetry like this, it is going to overlap. Okay, like this. So that means it is going to have 5 lines of symmetry. I have made 1, 2, 3, 4, 5. I have made 1 extra. Okay, but a figure, a pentagon is going to have, pentagon means how many sides? 5. So a pentagon is going to have 5 lines of symmetry. 5 lines of symmetry. Similarly, if I talk about hexagon, hexagon means 6. So hexagon is also a regular polygon which is having 6 number of sides. So if it is having 6 number of sides, that means it is going to have 6 line of symmetry. Okay, so this was your second point. Now the third point is point symmetry. What is a point symmetry? Point symmetry means if a figure is there with me, like for example this is the figure. If I am going to rotate it at an angle of 180 degree, it has to be symmetrical to this side. Now what I said like this, I am going to firstly rotate at an angle of 90 degree. If I am going to rotate it at an angle of 90 degree, this side will go up and this will become like this. Now again I am going to rotate it at an angle of 90 degree. Now what it will be there? This again is going to come this side, so this will become like this. So will you see, you can clearly see if this is the side, after 180 it became symmetrical to this. If this is this side after 180 became symmetrical to this. This is called as the point symmetry. Okay, so what is a point symmetry? First thing is after 180 it becomes symmetrical, and the second is upside down. It is having the upside down, it is going to have the same figure. Now you can read it. You don't have to go through this definition. You can see this note. A figure that possesses a point symmetry regains its original shape even after being rotated through 180. I have just explained you this 180. Now I am going to show you some of the examples in your book. In your book, for example, you can see this point symmetry. If you will see, this book is there and down also same. So that means this is a point symmetry. Triangle. If this is a triangle like this, can you see, is this the same? No, it is not same, because this here, if it has to be same, it should have been like this, and in this also like this it has to be there if it is a point symmetry, but this is not a point symmetry. So down also it has to be of the same, it has to be symmetrical. Next, a circle. Circle is having the point of symmetry. You can rotate it at any point, it will give the same shape. Now H. If H is there, just put it down. It is giving the same shape. Similarly, this A is not giving me the same shape. And the next, this ball. If this ball is there and I am going to keep it like this, it is going to give me the same shape. So that means this is also having the point symmetry. Okay, so only a few figures look the same when they are upside down. Such figures are said to have the point symmetry. Okay, now I have told you what is point symmetry, what is line symmetry. Now let's move to the questions of this exercise. First question of this exercise 14.1 is fill in the blanks. Question number 1 and 2 you will do in the book. A square has how many sides? 4. You all know it has 4 sides. Then how many lines of symmetry it will have? It will have 4 lines of symmetry. A regular hexagon. Hexagon means 6 sides. So that means it is going to have how many lines of symmetry? 6. A regular polygon with 15 sides will have how many lines of symmetry? 15. Now question number 2 is draw the lines of symmetry of the following polygon and fill in the blanks. Now what you will do in this question is you are going to draw. Firstly, you are going to see that how many sides are there in this figure. 1, 2, 3, 4. Likewise, you are going to count all the sides. So the sides are going to be 12. So how many number of sides are there here? 12. If 12 are there and this is a regular polygon, that means how many lines of symmetry it will be having? 12. And what is the name of the regular polygon with 12 sides? You call it as dodecagon. Or what you can say is regular polygon with n number of sides is called as n-gon. If it is having 15 sides, it will be called as 15-gon. It is having 12 sides, it will be called as 12-gon. You can call it as like this also. But there is a particular name of 12. If you want to learn it like this, you can learn it like this. Or if you want to write 12-gon, you can write that one also. Right? Now, let's move to question number 3. In this question number 3, it states, can we say that the figure which has n lines of symmetry is a regular polygon with n sides? For example, can we say that the figure which has 4 lines of symmetry is a square? Now let us see the answer. Answer is no. Not all the figures with n lines of symmetry are regular polygons. For example, just I showed you this. If I am going to talk about this rectangle is having 2 lines of symmetry. But this rectangle is not a regular polygon. Regular polygon means all sides should be same, right? But in a rectangle, opposite sides are only same, all sides are not same. So in this, only 2 lines of symmetry are there, but it is not a regular polygon. So we will be writing no, not all the figures with n lines of symmetry are regular polygons with n sides. For example, a rectangle has 2 lines of symmetry, which is not a regular polygon with 2 sides. It is having 2 symmetries, right? But 2 symmetries it is having, but this is not a polygon which is having 2 sides. So that means it is wrong. It is completely wrong what they have said. There has been an exception, and that exception is rectangle. However, it is a polygon of 4 sides, right? So this is your question number 3. Now let's move to question number 4. Complete the following figures such that the marked point is their point of symmetry. Now, on the basis of this point, if you are going to rotate this figure at an angle of 180 degree, what will be the position? You have to write this after 180. Now this circle you are going to rotate at any angle, it is going to be of the same shape. So a circle of any point of symmetry at any angle, it will be the same one. Now let us talk about this. Let us talk about this angle, this figure. Firstly, this figure is given to me like this. Let me show you, if I'm going to rotate it at an angle of 90 degree. If I will rotate at angle of 90 degree, it is like this. It is like this. It will become like this, vertical. So this will change to this, like this. Okay. Now again, let us see after 90 degree, what it will be. Now this is there. Again, I have to change to 90 degree and this is going to shift like this. So this will become the same. It will come to the same position as it was at the first place. So the point of symmetry of this is going to be the same. Okay. So the same figure I have drawn here. And you can see the reason why it is same. Now C part I have explained you with an example earlier only in the start of the video. So C part is this. I have just explained you the C part. Now D part. D part, if I'm going to talk about this symmetry, what will be the symmetry of this? After I just said upside down, it has to be same. So if this is like this up, then the down is going to be like this. Okay, so this is your point symmetry and this is all the figures. Now let's move to question number 5. Does a regular pentagon have a point of symmetry? A regular pentagon, if I'm going to talk about here, regular pentagon means 5 sides. Now let us rotate it at an angle of 90 degree. If I'm going to rotate it at an angle of 90 degree, this is going to shift like this. This line is going to come this side. I'm going to mark it like this. And this is my pentagon. Okay, 1, 2, 3, 4, 5. Yes, with 5 sides. Now again at an angle of 90 degree, what will come when I'm going to rotate? This line will come on the top and this will become like this. Now if I'm going to check these two, are these both symmetrical? If they would have been symmetrical, they would have been like this. If above is this pentagon, then it would have been like this. So that means after 180, it is not a regular, it is not forming a point of symmetry. Now look here. No, regular pentagon does not have a point of symmetry because it will not look same when it is viewed upside down. And this is the figure. Okay, so this is the answer of this. But if the sides are of even sides means I'm going to take this square for example. When I'm going to change this square after 180 degree, it is going to give me the same shape. Okay, so this you are going to learn afterwards in this chapter. This is the basic. I want to explain you the reason behind it. If the number of sides are even, they will form point of symmetry. That means same shape they are going to give after 180 degree rotation. Point of symmetry they will give. But if the number of sides are odd, like 5, 7, 9 and so on, they will not give us the point of symmetry. So this was your question number 5 and this was your complete exercise 14.1. So complete this exercise in your notebook. Thank you.